Hi, today we're going to look at similarity and congruence. We're going to quickly look at what both of those words mean, and then we will go on to how we will use similarity, because there's not much we can do with congruence other than identify shapes that are congruent, but then we'll go on to how we can use similarity to solve problems and things like that. So we'll start with congruence. We have 3 triangles here that are all exactly the same shape. They've just been turned around a little bit. And that is what congruent means. It means 2 shapes or 2 or more shapes are exactly the same shape and size. So I'm going to write that, so if you want to make a note, you can. So 2 shapes are congruent if they are the same shape and size. Okay, and it has to have those 2 things. They have to be the same shape and the same size to be able to be congruent. These 3 shapes on the other side of the page are similar. They are the same shape, but they are just enlargements of each other. And the really important thing to notice is that the angles within the shape remain the same. So even though the sides are bigger or smaller, the angles within the shape stay the same, and that is what makes it congruent. They are the same shape, just not necessarily the same size. And what makes them, and what proves that they are the same shape, is that the angles on the inside are the same. Okay, so 2 shapes are similar if they are the same shape. Similar, I feel like I'm spelling that wrong, if they are the same shape, not necessarily the same size. And we can tell that by the angles being the same. Okay. So now we know what they are. There's not much more you can do with congruence. An exam question would usually ask you to identify which 2 shapes are congruent, and you would just kind of pick them out. There's not much else we can do with that. But similarity we can use to solve problems, and work out missing sides in a similar shape and things like that. So that is what we are going to look at through the remainder of the lesson. I'll rub those numbers off. This was 5 and 8, and this is x and 12. I am going to show you 2 different methods. Oh, I didn't really want to use a straight line. I'm going to show you 2 different methods, so that you've seen both. One is using scale factors, and the other is using fractions, and then a little bit of algebra to work out what x is. The scale factor way is possibly a little bit easier, but the fraction way will hold up more in different types of questions. The fraction method will be more useful in more difficult questions, which we'll see on the very last example that I do. But we'll do the scale factor way first. So using scale factors, we know if we enlarge a shape that all of the lengths have to increase by the same amount, and that is what we call a scale factor. So we can match up the corresponding sides. So this 8 and this 12 are the corresponding, they're the same size, but from the original shape and the enlarged shape. So they are the corresponding side. The 5 and the x would be the other corresponding side. We need to use the blue highlighted ones to work out the yellow x. Okay, so we can work out the scale factor by working out what we've multiplied 8 by to get 12. We do that by dividing 12 by 8. So the scale factor is 1.5. So that's the scale factor. Okay, once we know that, we can then take this 5, multiply it by the scale factor because it's got bigger, so we'd be multiplying. If we were going the other way, we would divide. So basically, if we're going this way, we are multiplying by 1.5. If we were going the other way, you're dividing by 1.5 because multiplying makes it bigger, dividing makes it smaller. So to work out what x is, we are going to take x is 5 multiplied by the scale factor of 1.5, which is 7.5. And that's what x is. That's really easy. Okay, so you work out what the scale factor is. You either multiply or divide depending on which shape you're working with, and then you get the answer. The fraction way is still based on the idea of a scale factor, but if you divide the two blue sides, you will get the same answer as if you divide the two yellow sides, because the scale factor is the same each way. So it's using kind of equivalent fractions and a little bit of algebra and rearranging to work out what x is that way. So we knew if we do 12 divided by 8, you get the scale factor. But if you did whatever x is, obviously we know what it is now, but going back to the beginning, if we take whatever x is and divide that by x, we know we should get the same answer as if we do 12 divided by 8. So then we need to rearrange it and solve to find what x is. So I'm going to cross multiply. So I'm going to times the 5 over here and then the 8 over there. So 5 multiplies by the numerator to get 60, 5 times 12. And then the 8 multiplies by the x to get 8x. Then I'm going to divide by 8 to get what x is. 60 divided by 8 is 7.5. So we get the same answer as before. X is 7.5. Okay? Like I say, the second method this way with the fractions kind of holds up a little bit better depending on how difficult the question kind of gets. Okay? So let's keep going. We have two similar triangles here, but they are, one is within the other. So you have this small triangle, which is nice and easy to see here, but you also have the big outside triangle, and those two shapes would be similar. These arrows mean that these lines are parallel, and that kind of helps you know that they are similar. And again, the question would tell you, it would say triangle, oh, I didn't finish labeling them. Triangle ECA, so ECA is going all the way around the outside, is similar to a triangle DCB. Okay, and again, you follow the lines and that tells you where that triangle is. Those two triangles are similar. Work out the length of BD. So we're trying to work out this length here. I'm going to call it X. Okay? Sometimes, and I know it helps for me to draw out the triangles that I'm working with, so to draw them separately. So you have the big it hasn't come out the way I wanted it to. You have the big triangle where the base is 7.5. This length at the side is this full length here. So we need to add the 6 and the 4 together to get 10. And then the little triangle, again, it doesn't really look like that, does it? The little triangle like this, we have, this is 4 and this is X. That's what we're trying to work out. Okay, I'm going to use the fraction way, just because that's what we're going to use on the next question, so just to get us used to using it. So I know these two sides are the corresponding ones, and then these two sides, the 10 and the 4. So they are kind of pairs of sides that match up. So I'm going to do 10 divided by 4, and I'm going to put it equal to 7.5 divided by X. So I'm taking the corresponding sides and dividing them and putting it equal to the fraction of the other two corresponding sides. I'm going to cross multiply again, so I'm going to multiply X over to this side, and I'm going to multiply 4 over to that side. So I get 10x is equal to 7.5 times 4, 1530. And then I'm going to divide by 10, to get what x is. Divide by 10 gives me x is equal to 3. And that's it. Done. X is 3. Looks a lot more complicated than it is. You don't have to draw the triangles out like this separately, but sometimes it does help just to make it clearer which two triangles you are working with. A really common mistake if you don't do that is that you would say that this length is, that you work with this 6 rather than the full length, which is actually 10. Okay? And then the last question, this one gets again a little bit trickier because of where the x is. Okay, so if I draw out the two triangles that I'm working with, so I have this one, this is my big one. No, I'm going to do the smaller one first because that's easier. This is 5, oh, this is 5, and this is x. So the x is what I'm trying to work out. But on the bigger triangle, on the bigger triangle here, that's better. This is 8 here on the bottom, but then what's this length? Okay, I don't know what x is, so I can't work out the total length. It's still going to have an x in it, so this length is x plus 2. And this is why the fraction method becomes a little bit more useful, because sorry, somebody's hoovering outside and it's really distracting. Because we can use algebra to work out what x actually is. So match up your corresponding sides again. So 5 and 8 are your corresponding sides on the bottom, and then x and x plus 2 are your corresponding sides on the side. And then again, we're going to put 8 over 5, and we're going to put it equal to x plus 2 over x. I'm going to cross multiply again, multiply the 5 over there and the 8 over here, so I get 8x is equal to 5 lots of x plus 2. You're multiplying that full expression, the x plus 2, all of it by 5, which is why I've put it in a bracket. I'm going to expand the bracket, so I get 5x plus 10. I'm going to move the 5x over, so I have all my x's on one side, so I get 3x is equal to 10. So x is 10 over 3 because I've divided both sides by 3. I'm going to leave it as a fraction. I'm not going to try and change it to a decimal because it gives me a recurring number, and it's more accurate if I leave it as the fraction. So I'm going to just leave it as 10 over 3, and that is what x is. Yeah, and that is the length that you've been asked for. Yeah, you've been asked to find what x is. Yeah, so that's as hard as we're going to get today. I'm going to stop there. I hope that helps. I hope it makes sense. And thank you for listening. Have a lovely day.